My guess is that most of you are working with large-scale apps, high-profile projects, commonly creating web applications, mobile applications, generally corporate stuff that is kind of typical to our industry. JavaScript development, web development these days. And I wanted to show you two cases when we created interactive installations in the museum, in the Warsaw Rising Museum, that visitors to the museum can interact with. They enter the museum. They have some interaction with, and probably that's not the situation and not the project that you would consider web tech stack is suitable for. Maybe you will not see JavaScript and HTML or at first glance when I will show you the projects or the installations. Probably with my with this introduction you will see it there, but I guess that not many people do. I want to. These are kind of success stories on the contrasting to what Anton just said. That it's better to learn from mistakes. I hope you will find this kind of interesting or inspiring. That you can use this tech stack in slightly different scenario. I wanted to start with a video that presents the first installation, and then I'll just discuss or tell you more about the stack. Documentary short videos that are documenting the project itself. The first one is an interactive map of Warsaw that shows the overview of the pricing from day one to the end. It is using a projection from a projector that's hanging on top of the model of the city. The city is the model is 3D, but with a very low fidelity of the model, just to present the design or the animation to make it to be on the first stage of the presentation. And there is a control app, there is a display app. I will get into the details in a sec. We are showing the story of the pricing from day one to the end, but we have decided, working with the historians in the museum, we have decided to, or they decided to pick just a few days, like 15 or 17 days, the key moments, the key milestones of the pricing. So, okay, this is the architecture overview. What you have seen is basically the installation consists of two web apps that are running on the bottom here. We have a controller app and a display app. They are both web apps that are communicating with each other through Node. Controller app is connected. They are both working or deployed on the same PC. We have considered having a separate boxes for those. We were looking into performance, but we found out that just one PC is enough. Even though it's both connected in the same moment, it's connected both to a 4K projector and a touch screen. But the controller app is displaying the front end on the touch screen and display app on the projector. Okay, so that's kind of simple. Kind of simple technology here, and the main technology we use to make it work is NWJS. Does anyone here have any experience with Node NWJS? And do you have any experience with Electron? Yeah, so okay, I want to talk you to compare those two later. So we used NWJS, which basically wraps Chromium and Node and makes an executable out of that. So we can just run it on a PC or a Mac, just like any other program, and it runs full screen, handles the execution of the application without any problems. For the main part of the animation that you saw, we are using GSAP library, the GreenSock animation platform, which we are using a lot with websites, for websites and for these kind of installations. And probably that's the most complex part of the of this project, because the whole animation that you saw, so glimpses of, is pretty complex. There's kind of a lot going on, and GSAP helps us with creating the code in kind of a manageable way, so that we can understand it and change it with the designers, with the historians as well, throughout the project, and then come up with the final situation. I'm mentioning SVGs here because the infographics that is being animated is kind of complex SVG. It probably has tens of thousands of nodes, and it has different layers for different days of the animation, and all the layers are structured in a very similar way, and it's kind of complex, and we had to learn how to handle this complexity so that our designers can work with. So I'm mentioning here is what were the challenges of the project, and point two, SVGs. I started talking about it. We came with a process. So the issue was that we had different layers for different days, and they were having similar objects, and there were collision of IDs, and we had to develop a process of handling this kind of large file, so that the designer can work on the file in the Illustrator, Adobe Illustrator, and then commit it to Git, and then we had kind of automatic pipeline so that it was deployed to our test environment, and the designer could more or less by herself see or test the changes of the SVGs, which were a huge part of the implementation itself. The other challenge we had with this project was surprising for me. When we were doing the final mounting in the museum, we mounted. It was a challenge to mount the projector, and at first, even to choose the projector with correct focal length, so that the displayed image would fit the table with the 3D model of the city. At least more or less fit the table. But when we had such a projector, it was a hell to calibrate it, because we were able to both maneuver or change the position of the projector with in all three dimensions, and then we were also it was also possible to move the table around and rotate the table. And it was a hell to set it up so that it didn't have any distortions. And actually, we learned that we really need an arm, and a projector arm with a micro adjustments, and we didn't. So it was just a tiny bit of a modification on top, resulted in like 3, 5, 10 centimeters of change of the image on the table. But then at the end, when we finally managed to more or less fit the image with the table, with our this test image with the grid, it turned out that there's 1 or 2 millimeter differences when we focused on the actual model of the city, where it had modeled the streets and the river. That it was visible enough. These distortions were visible enough, so we had to have another phase of micro adjustments of the both the satellite, or maybe not satellite, maybe yeah, probably. I don't remember whether it was a satellite image of the city. So it would have to be from these days. So maybe it was just a plain photo of the city from the 1934. And we had to distort it in Photoshop and then adjust the positions of the of all the elements in the SVGs. And then final thing I want to mention here, just the whole installation had to start up every day and shut down during the night. And we managed starting up of these NWJS applications. It was pretty simple. Because they were executables, so we managed this with Windows Scheduler. But then it was kind of an issue to start up, automatically start up the projector. And what we actually did was use the web app, admin web app of the projector that was available over the Ethernet that allowed a user, like a human user, to use a browser to to manage the projector, for example, to start it up. But we didn't have an operator there in the museum during every morning, so we screen scrapped the HTTP commands that the browser was sending when a user was operating that, and we used a terminal script with curl commands to simulate the actual user starting up the projector using the web app. Okay, so that's the first thing, and for the second year, we kind of decided to top up the game, and we worked on another idea of ourselves. That's called reflection. In the beginning, it was called Sibling. The idea was that we could use the huge library of photographs from the epoch and try to use AI to find a sibling of a visitor, of a user of a website, similar to someone from one of the insurgents that is similar to you. And actually, reflection is a mirror. Actually, there are two mirrors, one behind the other. The mirror is actually an interactive mirror. It has a webcam. It has a screen behind the mirror, so we can use it both we can both use it as a mirror and as a screen. For this installation, actually the architecture is even simpler. And again, it's what visitors see is actually a web app as well. The mirror app is actually a website with some specific API calls, but basically it's a simple web page. Sorry, not even web app. It's just a web page with a few API calls, and it's running in a container that was provided by the producer of this interactive mirror. We actually, for this project, we created a dedicated, bespoke design of the mirror, but the technology is similar and they are using it in different places. And the mirror app is connecting or sending requests with images, of the visitors to the AI app, which is actually called, which is developer coded in Python. I will get back to that in a second. And then the AI app sends back the response, which is the ID of an insurgent that we want to present the image of. The mirror has two specific pieces of equipment that I wanted to mention. One is the webcam, and the other one is the distance sensor. So we can measure, or our application has information or receives events from the container, which tells the information holding, or events holding an information how what's the distance from the viewer to the mirror itself. Actually, key technologies used here are as even simpler than before, because we are using again GSAP for seamless animations between the different stages of the interface of the applications. We are using Axios for these calls, and then RxJS for managing events with regarding the distance that I mentioned, which were produced sometimes even a few times a second. So we didn't want to be overflown with the events. So yeah, so we used RxJS for that. The AI application is a large topic and probably would require a whole separate presentation on Python.js maybe. But what I wanted to mention is that the first prototype of the application that we created had this part also coded in a Node, so it would be probably possible to code it with fully with JavaScript, or maybe the JavaScript would be a kind of a wrapper for the Python TensorFlow implementation, which is probably better, or at least was 2 years ago. There were quite a lot of challenges with this project. I wanted to mention these connected to the interface, to the web application. One is lighting. So there are two sides of the story with lighting. The more light we have, the better the mirror effect works, because it reflects the external light. And on top of that, the better images from the webcam we get. And we wanted to get pretty decent images, so that the Python AI implementation could recognize the features of the face and then analyze that. But the flip side of that, or the other side of the coin, is that the more light we have, the worse we can see the screen that is behind the mirror. So setting the light up required a lot of different trial and error effort. To add the light, remove light, move it to another position, change the direction. It was a hell. Then the webcam position is kind of having the AI part of the webcam positioning created the only algorithmical problem in this project. So we decided we couldn't have a webcam in front of the viewer, because in front of the viewer we have a screen behind the mirror. So we decided to have it. We could either have it on the side or on top or on the bottom. We decided to have it on both to suit both tall people and kids. But having a webcam on the side meant that we are making the pictures of the visitors just side profile, slightly from the side. It was better when they moved slightly backward, and worse if they were closer, but still it was a problem with this position. So what we created was a kind of a design decision that we put elements of the interface in different places, and they were appearing and disappearing during the kind of preliminary introduction animation. And the moment that we were making the photo, all the interface elements was appearing close to the camera, so the users slightly moved their head towards the camera, so that made the trick. And the other thing that the other consequence of having a camera, actually in any place, was that or the issue that we had to solve was to find height of the visitor, so that we could just using our screen, we could show the image of the insurgent in the place. So we had to get the coordinates of the place where the visitor sees their reflection of their face, and that varies. So this position varies whether someone is tall or small. So we had some algorithm that so we had to combine. I won't get into the details about that, but we analyzed. The only thing that we had to analyze was the image from the webcam, and yeah, we just trial and error. We decided to, or we found out the correlation between the position of the face on the image from the webcam and the correct position that we had to show the image on the screen behind the mirror. Later I can tell you more about it during the networking session. And wrapping up, hopefully that was kind of interesting for you, or surprising to see that these kinds of things, these kind of projects are possible with web tech stack. I want to wrap it up with things that make, from my point of view as a developer, that make it different, or these kind of projects are different. So one is that these projects are very tight on schedule. So they are 1, 2, maybe 3 months long projects, and they end when they end. We don't support this. We don't support, and which is maybe even more important, we don't create new versions of these kind of applications. And this means that from the software craftsman in myself cries. So there's a lot of dirty tricks, but yeah, it doesn't matter. So I would like to refactor, but it's not very important. And then the other thing of the story is that I had some parts of my career working on corporate systems for telcos and for banks, and doing these kind of projects, I think that, or I feel that these serve some better public or common purpose. So you get both in the same time. You don't get as much, well, craftsmanship as you had, but there are some other benefits. Thank you. Hopefully that was kind of interesting.